Hi, in this lesson we're going to work with how to write algebraic expressions. Now before we do that, we first have to understand a few vocab words that are going to make us more successful in writing algebraic expressions. So you ready? Let's begin. The first vocab word we have to be really good with is a variable. What is a variable? A variable is any letter or symbol that represents an unknown item. So for example, let's say I was referring to watermelon. Because I have no idea how many watermelon we have, I can associate the letter W for watermelon. A letter that we've all been working with ever since pre-algebra has been solving for the letter X. The letter X always counts as a variable. Now let's say I was referring to how much money does Jessica have in the bank. The main person that we're referring to is Jessica. What letter would Jessica get? I would associate the letter J for Jessica. So pretty much a variable is just any letter that you want to associate, or it could also be a symbol, but mainly it's usually going to be a letter. The next vocab we're going to have to understand is what is a constant? A constant is any real number. The first constant you can think of is the number 4. My favorite number happens to be 2. That also counts as a constant. What's your favorite number? That favorite number you just thought of, that's also going to refer to a constant. Now, constant is usually confusing whenever you see in a word problem, but whenever they say find the constant, they're just looking for the answer, which is going to be a real number. Okay? Moving on to the next one, it's asking you, what is a numerical expression? A numerical expression is when you combine two or more constants, which what are constants? Numbers, two or more numbers by any basic mathematical operation. So for example, let's say I was doing 3 plus 10. That would be a numerical expression. What about 5 minus 8? Also a numerical expression. 3 times 10. Also a numerical expression. So numerical expression is just combining two or more constants, which are just numbers, by a mathematical operation, which we'll get into mathematical operations in a few slides. Last one, what is an algebraic expression? Now this is the one that's the most important one because this is what we're going to be solving today, or writing. We're going to be working with different constants and letters. And we have to know what they all represent and different meaning of it. So an algebraic expression is just two or more constants or variables being combined by a mathematical operation. Wait, let's think about that. Two or more constants, we know constants are numbers, variables are letters. So when you solve them or write them with a mathematical operation, that's going to be an algebraic expression. Okay? So here's an example. X minus 5. 3y. 2x plus 5y. All of these count as an algebraic expression. Why? Because there's two or more constants or variables in an operation. Okay, so those are the first vocab words that we have to just understand because when we see them in a word problem, we just have to know what they represent. So, are we ready to begin? Okay. Before we get started with the actual problems, we have to know what are the most important mathematical operations that we can work with. The 4 most famous operations that we are always going to work with, which you saw for last year and the years before that, is an addition, subtraction, multiplication, and division. Addition has words that you want to know that get associated with addition. For example, adding, sum, increase, more than. The one that you want to place close attention to is more than. When it comes to subtracting, you're going to see words like subtracting, fewer, less than, minus. Most of those words are going to make sense on why that's subtracting. However, the word less than, you have to also understand because it plays a little bit more of a role when you're reading a question. Multiplication, multiply, product, times, of. The words that you want to pay closer attention to when it comes to multiplication is product and of. Every time that you read or see the word product or of, this is going to always represent multiplication. And lastly, division. Obviously, divided by makes sense, but whenever you see the word quotient, ratio, or even sometimes you see the word fraction, all of these words always represent dividing two or more items. Okay? So this is just pretty much the most famous words that get associated, but there's plenty that you see that also represent the same amount, okay? So now we're going to actually begin solving for an expression. The first question says, write the sentence as an algebraic expression, the sum of 6 and the number x. The first thing you're going to notice is when you read this sentence, it says the sum. When the operation is in the front, there's usually going to be an and somewhere behind this word sum. The sum of 6 and a number x. We all know sum represents addition. So a shortcut and a trick that you could do and use to help you out is take that addition and put it where the and is. Why? Because you're going to write this expression in the order that you see it. So for example, 6 comes first because you see the word 6 or the number 6. And we said, what are we going to replace with and? The plus sign because it's sum and a number x, which is our variable. So how do we write this algebraic expression? 6 plus x. Now, can we use this trick every time? No. Because sometimes the main operation isn't going to be in front of everything that you're going to see, which is going to lead us to a future problem. However, when you see the operation in the front, look for an and so that you can take that operation and put it where that and is. So you ready for example 2? Let's get started. 5 more than a number p. So once again, 5 more than a number p. You're going to notice now in the beginning of the problem is our constant, our number. But you're going to notice the word more than. What does more than represent? Hopefully you remember a few slides ago we said more than, less than are the words that we want to know for addition and subtraction, but more than represents addition. However, whenever you see the words more than or less than, the number that came before it always goes to the back. Once again, every time that you read the word more than or less than, that number that you read always goes in the back. So for example, since I saw 5 more than, I know in the back is going to be a plus 5. Well, what's going to be in the front? Whatever comes after the more than, a number p. So what goes in the front? P. So how do I write this algebraic expression? 5 more than the number p is simply going to be 5 more than in the back. What's in the front? The letter, which is p. P plus 5. Now, why is that? Let's come up with a scenario. I have $5 more than Paul. $5 more than Paul. Well, if someone was listening to our conversation, they'd be like, well, how much money does he have? They'd never know. Why? Because we don't know how much money Paul has. So the first thing that person that was listening to our conversation has to understand is we first have to find how much money Paul has and then add 5. That's why every time that you read the word more than or less than, where does it go? In the back. Now that's something that you want to write down in your notes because you're going to see this over and over again, and sometimes we kind of forget. So moving on to the next example. 3 less than, stop. Less than means what? Subtracting, where does it go? In the back. So what am I going to do in the back? Put a minus 3 right away. 3 less than, a number c. What goes in the front? C. So it's just c minus 3. Was that okay? All right. In any of these problems, stop the video. Try solving it and then watch it so that you can see if you get it right or wrong. So now example 4. 7 more than the product of 2 and a number t. Now if you stop this video, you're going to notice this question is actually a little bit different for one reason. The one reason is that there's a multi-operation in this problem. You see the word more than, which we know goes in the back, it's a plus sign, but you also see the word product, which represents multiplication. So what do we do when there's multi-operations in a problem like this? This is what we do. We treat it like normal. 7 more than, what does that mean? We're going to put plus 7 in the back. The product of, what does product represent? Multiplication. But if you notice, it's the product of 2 and a number t. This entire problem over in the back end is by itself. We're going to multiply, because we read the word product, 2 and a number. Remember we said when you see the operation in the front, what can we do? We can take that multiplication symbol and put it where the and is. So what am I going to multiply? I'm going to multiply 2 times a number t, and then I'm going to add 7. So how do we write this as our final answer? Our final answer is going to be 2t plus 7. And that's our final problem. Okay? So let's read it one more time so we can make sense of it. And then we'll kind of go into different problems that represent multi-operations. 7 more. What does that mean? 7 more than? Put in the back. The product, what are we about to do? We're about to multiply. What are we multiplying? 2 and a number t. So it's going to be 2t plus 7. Hopefully that made sense. Example 5. Remember, stop the video and try if you want to. 6 times the sum of a number a and 5. So I see 6 times. I know times represents multiplication, so it's going to be 6 times the sum of a number a and 5. So once again, this represents right here addition. What am I going to be adding? I'm going to take the plus sign, put it where the and is. So on the side, I'm going to put a number a, so that's going to be a plus 5. How do I write that? 6 times a plus 5. Now, if you write it like this, it looks like that 6 is only being multiplied to a, but if you notice, it says 6 times the sum. So I have to first find the sum and then multiply by 5. By 6, I mean. So what does this mean? I'm going to use a parentheses. So that if my final answer would be 6 parentheses a plus 5. I'm going to first find the sum of a plus 5 and then multiply by 6, and that's my final answer. Not bad? To be honest, these are a little bit trickier because every time that we work with multi-operations, we have to understand the structure, and it's just based on the format. Order matters when it comes to this. Okay? All right. So we have a few more. 2 more left. The quotient, I'm going to stop. What does quotient mean? Quotient represents division. What am I dividing? 10 and 2 less than a number x. There's a lot of operations there. So what am I going to do? Because quotient came first, I'm going to take this quotient symbol and I'm going to put it where the and is. Why? Because I know that anything left of and is going to go on top for a quotient, and anything behind and goes in the bottom. So what does that represent? The quotient, I'm going to set up a fraction because I'm going to be dividing. 10 goes on top in the numerator. What goes in the denominator? 2 less than the number x. But if you notice, this right by itself is its own problem. 2 less than, where does less than go? In the back. So we're going to put minus 2. Less than what? Less than a number x. X minus 2. Where is that all going to go? Because it comes after and, it should go in the denominator, which is the bottom. And that's my final answer. So reading this problem once more, the quotient represents division. So I'm going to divide whatever 2 things they're referring to. 10, that goes in the numerator because that comes first, and 2 less than a number x. 2 less than a number x is its own problem. Less than goes in the back. Back of what? Back of the variable, which was x minus 2. And that goes in the denominator because we're dividing 2 different things, 10 and x minus 2. Not bad? Okay, let's try our last example, which is example 7. Now, example 7 is going to be a word problem, but at the end of the day, it all represents the same thing. LeBron makes 30 baskets every hour. LeBron makes 30 baskets every hour. First, I'm just going to understand, makes 30 baskets every hour. So every hour, 30 baskets. 1 hour, 30 baskets. 2 hours, 30 plus 30. 3 hours, 30 plus 30 plus 30, because every hour he makes 30. Write an write an expression for how many baskets LeBron will make in H hours. So they want us to use the letter H. Every time that you read words such as every or per, that actually represents multiplication because it happens every time. If I had to add, let's say, 100 hours that LeBron plays basketball, there's no way I'm going to do 30, 30, 30, 100 times. It's too tedious. So what's an easier way when it comes to adding the same thing over and over again? Let's multiply. So this is going to represent 30 times however many hours he's going to be playing basketball. So how do I write this in an algebraic expression? 30h. And that's our problem. So to be good with word problems, we have to always associate the words every and per, usually with multiplication, when it happens consistently. Not bad? Okay. So in our last slide, we just want to remember a few things. We had 4 vocab words that we had to understand. The first one was a variable, which was a letter or symbol that represents an unknown item. What's a variable? A letter. Next came constant. Wait, what's a constant? Any number you could think of. Remember we said your favorite number. My favorite number. Your favorite number. Your teacher's favorite number. A constant is just a number. Okay? Next came numeric expression. Numeric expression was just combining 2 or more constants, which are numbers, by any mathematical operation. Wait, what are the 4 most famous mathematical operations? Addition, subtraction, multiplication, division. And lastly, the most important one, which were our problems that we had for today, algebraic expressions. What's an algebraic expression? Working with 2 or more constants or variables combined by a mathematical operation. Okay? So hopefully this video helped you all. Thank you for watching and best of luck.